Okay, so 6.3, we had factoring trinomials with a equal to 1. And the only thing we really had to be concerned about were the signs inside of our binomials once we had it factored, and then what factors of c added or subtracted together to give us our middle term. Today is a little bit more complicated because our leading coefficient, that a value, is not going to equal 1. And so we're going to have to take it into consideration when we're doing our factoring because it's going to come in. When we multiply the first of when we FOIL and we do the first things, that happens. But then also when we do our outer, that first coefficient affects what happens to that middle term. And so there's two different ways we're going to kind of approach these. One is trial and error, and one is factor by grouping. We will do a set of problems for each of these. The trial by error is really the best way to go about any type of factoring. But as I have mentioned before, if you have a box method or a cross method or I don't know what the other methods are, but if you know of a different method that you are already comfortable using, feel free using it. I have no problem with you using another sound mathematical method. But I'm going to show you by trial and error. So trial and error kind of works with these steps, but really we're going to have to treat every problem uniquely because not all of these are necessarily going to apply. Like step 1 says factor out any of the greatest common factors. We actually did that on the last couple of problems in 6.3, where we saw that a 3 was in common with all of our terms, and so we went ahead and took that out. You're always going to want to do that if that is available. A lot of our problems are not going to have a common factor for us to factor out, but if they do, that should always be your first step. Because as we saw last time on our last couple of problems in 6.3, our A wasn't initially a 1, but by factoring stuff out, it did become a 1, and that made our overall factoring a lot simpler. So always look for that. This next step you want to do is write all the pairs of factors for your A term. So if your A is not equal to 1, we need to figure out what times what will give us A. That way we can figure out what's going to go inside of our two binomials that we're going to end up with. Step 3, we're going to write all the pairs of factors for C. We have already been doing that, but now we're going to have a lot more options or different combinations that can happen. And so it's nice to have those written to the side, so when we are pairing things up, we know which ones we've tried and which ones we haven't. And then step 4 is then try combinations in order to obtain your middle term, that BX that's in the middle. That's why this method is called trial and error. It's because you're going to try some things and they're not going to work, and then you're going to try some new things and maybe they will. One thing that I have always recommended for students is when you start setting up your binomials, you can set up certain parts of them with a pen, and then you can set up other parts with pencil so that you can erase just certain parts of it instead of having to erase your whole binomial. And I'll show you what I mean by that. Again, you don't have to do it that way. You can do it however you would choose. I like to not have to erase every single thing that I do. So those are kind of the suggestions on how to approach the problems. We're going to do 4 of these before we talk about factor by grouping. So first one is 3x squared plus 20x plus 12. We should always look to see, can we factor anything out of all of these terms? Well, 3 and 12 both have a 3 in common, but 20 doesn't. 20 has a 2 in common with 12, or even a 4 in common with 12, but 3 doesn't. So there's not anything that we can pull out of all 3 of the terms. So step 1 is irrelevant for this problem. So step 2, we're going to write out all the factors of A over here to the side. Luckily, there's not very many because A is prime. And when you are a prime number, the only factors are 1 and 3. So that greatly simplifies what our options or pairings are going to be. And then I'm going to write out all of the factors of C. C is 12, so I have 1 times 12, 2 times 6, and 3 times 4. So those are kind of just notes for me over on the side. Now over here, I know I'm going to be factoring these into two binomials just like this. I further know, because my sign in front of my C is positive, that the signs inside of here are going to be the same. Since my sign in front of my B is also positive, I know these are going to be plus plus. So I can go ahead and put that in. And I know my first term is an x squared. So just like last time, I know I'm going to have an x and an x. And this problem's even nicer because since we have a plus plus in here, and we only have one factor for our a term, it doesn't matter which one we make 1 and which one we make 3 in the least. So I'm going to leave 1 here and 3 here. If you are more comfortable with actually writing a 1 in there, you totally can. But these are all things that I know for a fact have to be. And so I write them in pen. My second term inside of my binomials, I don't. So if I don't want to have to erase and rewrite this binomial over and over again, oftentimes I will shift over and use a pencil until I figure out what pairing is actually going to work. Again, you do not have to do that. I do it mostly to save space on paper. So now here's what we're trying to achieve. We need to get a 20x in this middle term. We need to get a 20. Right now we have 1 times 3. We're going to have a 1 times something and a 3 times something, and we need that to add up to a 20. That's what we're trying to figure out. So if you don't know where to start at all, just start with your first factor of C, 1 and 12, and see if it works. If I put a 1 in here and a 12 in here, if I do my outer inner terms of my FOIL, am I going to get 20? 1 times 12 is 12. 1 times 3 is 3. That would give me 15. That does not give me 20. So what if I switched them? What if I put the 12 there and the 1 over here? Does that make it work? I'd get a 1x and I'd get a 36x. Definitely does not work. So because I tried it both ways, I know for a fact 1 and 12 cannot be my ending term for this binomial. So I've just eliminated that term out. Then we can try 2 and 6. 1 times 6 is 6. 2 times 3 is 6. That'll give me 12. That doesn't give me 20. So I'm going to switch them again. That's what's different about 6-4 versus 6-3. In 6-3, if we tried it and it didn't work, we knew it didn't work. But if we try it here, because we have not just ones up here, we have to try it both ways. So here I have 1 times 2 is 2. 6 times 3 is 18. That does add up to 20. So this would be my factor. And this is why this method is trial and error. We had to try a couple things. We weren't sure exactly where to start. But as I mentioned, these come easier the more you've played with them. And so the more you play around with them, you'll start looking for things like, well, what can I add to get to 20 using these different factors? And you would look at 1 and 12 and say, I know that's never going to work. Or you would look at 3 and 4 and say, I don't think that's ever going to work. And so you will be able to eliminate out some of your factors after you've played around with them more and you get more comfortable with what it is you're looking for. Do we have questions on this one? Or need clarifications on anything?
3 and 1.
The 3 and the 1 are the factors of your A. Because that's what's going to add together when we do our first and our FOIL method to give us our 3x squared. And luckily, that's the only factors of 3, so we don't have to consider anything else. Some of them won't be quite so nice. Our fourth example will not be quite so nice because there'll be more factors for A than just 1 in itself. But a lot of times they're prime, and that does help it a little bit. Other questions or clarifications? trying to keep those steps up there. Here's another one. We're going to do 5x squared minus 7x minus 6. Each of these that we go through will get just a little harder. So this one's a little bit harder because our signs are different. We have negatives inside of there. But we're still going to approach it the same way. First thing, we're going to see if there's a common factor. 5 and 7 are both prime, so that's a pretty good head start that no, there's not a common factor. Because if you have two prime numbers there, then they're not going to be factors of each other. So there's nothing in common that I can pull out of all three of my terms. So I'm going to list out my factors of A and my factors of C. That's what I'm going to start with. My A is 5, so once again we luck out because that's prime. Not 5, that's a 5. I was looking at the problem above it. So the only factors are 1 in itself. So that helps us a lot. We're not going to have to try multiple things in multiple spots. Our C in this case is 6. So we have 1 times 6 and 2 times 3. So even that, we only really have two different pairings that we can play with. So that's not too bad. Now when I go to set up my binomials, I'm going to write down everything I know for a fact. I know that I have an x squared. So again, I'm going to have an x and an x. And the only factors of 5 are 1 and 5. But my signs may make a difference here. So I'm going to hold off on writing my 1 and my 5. The reason why is because the sign in front of my C term is negative. And when that's negative, that means I have a plus and a minus. So where I stick my 5 may greatly determine the total outcome of this problem. So I'm not going to write my 5 and my 1 in with a pen, but I'll go ahead and write it in with a pencil, because I may have to move them. Now, what I'm looking for is I'm trying to get a negative 7x here in the middle. That's my goal. And if you don't know where to start, just start by plugging in the factors of 6. We can start with 1 and 6. And we're going to do our outer inner to see if we get to negative 7. Our outer would give me a negative 6 plus 5. That'll give me a negative 1. So that does not work. What if I switch them? Then I would get a negative 1 and a positive 30. That's really not going to work. That's way too much. Let's try 2 and 3. 1 times 3 is 3, so that's negative. Okay, so right here, we're close. 1 times 3 will give me a negative 3x plus 10x. That gives me a positive 7x. I need a negative 7x, though. So what do I need to do? Yeah, I can switch those signs out, can't I? Since I already wrote the signs in pen, though, that means I need to switch. Like I need to put 5x plus 3 and x minus 2. I need the 5 to go with the 3 and the x to go with the 2. Now when I do it, I take 5 times negative 2, giving me a negative 10. 3 times a positive x, giving me a positive 3x, which would result in the negative 7. So this one we did have to move some stuff around based on our signs. Obviously, if you didn't put in pen the sign, you could just have easily changed the sign and been done with it. On the next one, I'll leave it a little bit more open for us to play around with stuff. Again, foiling is going to be your friend in all of these sections because you can always check your answer by foiling it back out. And if you foil things back out and you don't get back up to the top, then you've either FOILed wrong or you factored wrong. Questions or clarifications on this one? Okay, let's look at another one. I'm going to end up taking the steps off just so that we have room. (3x squared plus 7x plus 5). This one's a really nice one. And the reason why I say that is all three of our numbers are prime. So I know nothing's coming out of all three of them. Second thing is when I look at my a term, my a is 3. So there's only one set of factors for that, 1 and 3. My c term is 5. So the only set of factors for that is 1 and 5. So there's only a couple different ways this can go, which is really, really nice. The other thing that's really nice about this one is they're both positive in here, which means inside of my binomial, it's going to be positive, positive. So this one's not too shabby. I know I will have a 1x and a 3x because I have to get to 3x squared. Because the signs are both positive, it doesn't matter where I stick those. So the only thing that's going to change is where I stick my 1 and my 5. So because this one only has two options, I'm going to write another set down here just so that we can see exactly what's going to happen when we stick our 1 and our 5 in the different spots. Okay, for this first set of binomials, if I do my outer inner, I get a 6x and a 3x. That gives me a 9x. We're looking for a 7x. So that didn't work. That's not 9, that's 8. I can't do math this morning. 5 and 3 makes 8. Okay. If we look at this one, we have a 1 times 1, which is 1x, a 3 times 5, which is 15x. So that gives us a 16x. Again, that's not 17x, which is what we're shooting for. But those are the only factors we have available. We've got no other combinations or anything else to substitute in. So what does that tell us about this trinomial? It's prime. We cannot factor it. We tried every option that we have available. So we say this is prime, not factorable, or cannot be factored, or however you want to put it. I'm pretty sure factorable is probably not an actual word. It might be in math, though. But if you exhaust every option and it doesn't work, it's prime. One of the things to kind of look for, which isn't the case in this one, but a lot of times your prime ones, this number in here will be dramatically smaller than the two numbers on the outside, and thus there's no way to add or subtract to get to that number. Especially if both of the signs are going to either be positive or negative. If you're trying to get to a smaller number than what's out here, that's almost impossible to do. So just look for that. Look for that middle number, and that might help you to identify the prime ones a little bit. Okay, we're going to do one more, and then we're going to learn how to factor by grouping. D, we have 6x squared plus 19xy plus 3y squared. (19) and 3 are both prime numbers. They don't have anything in common, thus there's nothing that's going to come out of all three of my terms. So I didn't have any that did that. This one's different than the other ones we've worked today because we do have an x squared and a y squared term in here. But that's okay. It just means the second term in each of our binomials is going to contain a y, where the first term always contains an x. That's not going to be a big deal. So we still approach it the same way. My a in this case is 6. So I have 1 times 6 and 2 times 3. My c in this case is 3. So I have 1 times 3. Still break it up the same way, still approach it the same way. Both of my signs are positive, so inside of my binomials are going to be positive. Makes our life nice. My first term of my trinomial has an x squared. That means the first term inside my binomial has to have x's. My last term has a y squared. So my last term inside of my binomials has to have a y. Because when I do my first in my FOIL, I'll get x squared. When I do my last in my FOIL, I'll get my y squared. All of these things I know, no matter what becomes the values in front of them. And I can even go one step further, but not with my x terms. But I can go ahead and plug in the ones here for my last terms inside my binomials, because there's only one set of factors for c. It's 1 and 3. And since the signs are both positive, it doesn't matter where I stick them. So I can put the 1 here and the 3 here. So the only thing I'm going to have to trial and error is what goes out here in front of my x's. Is it going to be 1 and 6? Is it going to be 6 and 1, 2 and 3, or 3 and 2? That's what I've got to figure out. And I'm shooting to get 19 when I add up my outer inner. So which pair do you want to try? Do you want to try 1 and 6 or 2 and 3? Do you have any inkling on how we're going to get up to 19? 1 and 6. That's a really good guess, because I know I'm going to have to take 3 times something. And if I take 3 times 6, that'll give me 18. That's really close to 19. So 3y is going to be multiplied by this one. So I'm going to put the 6 out here. And I'm going to put the 1 in here. Because when I do my outer, 6 times 3 is 18. Inner, 1 times 1 is 1. 16 and 1 does give me the 19. Those are the kinds of things that you can kind of start looking for. And you can kind of start logically thinking about before you actually plug any of the numbers in. How am I going to achieve this middle number if I know I have to multiply something by 3? How do I get there? And if you don't see that, then again, you can just pick one of the pairs. 6 and 1 are the first ones I would pick. I would probably write the 1 here and the 6 here, and it wouldn't work, and then I'd flip them. But that's still not a lot of trial and error necessarily. There's not a lot that you have to guess with on that. Are there questions on this? Notice on all of these, we are not solving. I've said that almost every lecture, but I want to really, really iterate that. We are not setting these factors equal to 0. We're not finding out what x is. We are just factoring. So don't take it another step further and do magic math. Are we ready to learn how to factor by grouping? Okay. Factor by grouping. This is another way to solve the trinomial. I will be 100% honest, I don't really love this method, but it clicks for a lot of people, and so I do like to teach it. And we actually saw this a little bit in 6.3. There was a couple of them where we did factor by grouping. I mean, that was a lot of what we did, but the middle term was both x's. And I told you that was weird because usually we would combine those and then factor like the old-fashioned way. But if you don't want to factor the old-fashioned way with trial and error, then we can do this factor by grouping. So factor by grouping is where you factor out, again, any common factor that we may have between all 3 of the terms. That's always step 1. Step 2 is we have to determine what 2 numbers whose product equals a times c and whose sum is b. Step 3 is rewrite B as the sum difference of those two terms found in step 2, and then you factor by grouping. One of the reasons why I do not love factor by grouping in terms of factoring a trinomial in this form is because of steps 2 and 3. You have to basically memorize this extra set of rules that only work with a trinomial that's set up in the right format. And most of the time, you may memorize it or be able to reference it on your homework and quiz, and then when test day comes, you blank. And if you don't learn how to do it by trial and error, you've got nothing to fall back on. So over the years, I have contemplated removing this part, but I also really like to cater to different learning styles, and so I will show you this way. You may do either method, or like I said, if you know additional methods to factor with a box and things like that, you may use those as they work. But I will show you how to factor by grouping with these. Usually, which is what 6.3 was, or 6.2, we factor by grouping whenever we have like an even number of terms. Like when we have a polynomial that has 4 terms, and then we would look and we said, okay, what do these two terms have in common, and what do these two terms have in common? And our goal was to always get the same thing in the parentheses, and we factored that out. That's when we like to see factor by grouping. This factor by grouping is with a trinomial. So it's with the problems we've already been playing with, but we have to make it have an even number of terms, and that's what step 2 is talking about. We have to determine the two numbers whose product is going to give us our A times C and whose sum adds up to B. So that's the additional stuff you have to look at. Which is why I don't love it, but we will do some. Let's do 3x squared plus 20x plus 12. This was the first problem we did the other method. And I specifically made this the first problem of factor by grouping so that we will see we get the exact same factors. It works regardless of which method you choose to use. And you can pick which one suits you more. So we already know from when we worked it earlier, there's nothing that 3, 20, and 12 have in common. And so I'm going to write out what my A, my B, and my C are, because I need to know what all these values are. My A is 3, my B is 20, my C is 12. Now I need to figure out what A times C is. This is the first step if you do factor by grouping. A times C would be 3 times 12, which is 36. The reason why we have to find A times C first is because now we're going to list all of the factors of A times C that are going to add up to give us B. So the factors of 36 are 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Okay, good, I didn't run off the screen. 36 has a lot of factors. So now, which of these add up to give us 20? 1 and 36 doesn't. That adds up to 37. It's too big. Does 2 and 18 give us 20? Yes, it does. So I need to split my 20x into 2x and 18x. That's what I'm going to do. And I'm going to put the 18x first. Because when I'm, whoa, let me throw my pen. What I'm doing is I need to split that. And my first term is this 3x squared. And remember, when you factor by grouping, you want the first two terms to have something in common. If I put a 2 there, 3 and 2 don't have anything in common. But 18 and 3 do have something in common. So that's why I'm going to list the 18x first. Then I'm going to list the 2x, and then I'm going to put the 12. So what I did was I split my 20x into 18x and 2x. Why? So I'd have 4 terms, so now I can factor by grouping. So I look at my first two terms, 3x squared plus 18x. What do those have in common? a 3, what? X, that's right. Leaving us with an x plus 6 inside. Then I look at my next two terms and say, what do they have in common? A 2. Leaving us with an x plus 6 inside. Remember, the whole point of factoring by grouping is we get the same thing inside of our parentheses, because now we have one term right here, and we have one term right here. So if I look at those two new terms, they both have an x plus 6 in common that I can pull out front. And when you pull that out front, whatever's in front of those parentheses is what goes in your second parenthesis. That's exactly what we got when we factored by trial by error. X plus 6 times 3x plus 2. Trial by error, we got 3x plus 2 times x plus 6. Same thing. Notice the amount of math, though, or the amount of writing I did here for trial by error versus the amount of stuff I had to do here. If you're a person who likes to follow lots of steps, maybe this factoring by grouping you prefer, because you're like, okay, I take A times C, I write out the factors of that, I figure out the middle, I split, and then I factor by grouping. That's fine. And again, if you don't like factor by grouping, do it the old school way with trial and error. All of these problems can be worked either way. Do we need any clarification on this, on what we did, how we did it? Obviously, we're going to do some more because it's kind of unique and different. Okay. Let's look at B. 5x squared minus 7x minus 6. Again, this is the same B as before. Are we working all the same problems? Almost. D, our very last problem, will be different. So, first step, there's nothing to factor out of all of them, so I'm going to say my A is 5, B is negative 7, and C is negative 6. On the previous problem, we didn't have to put indicators on the values because they were all positive. If you have negative values, you do want to list them as negative values because that greatly affects what's going to happen whenever we start factoring these. So after we've listed A, B, and C, we want to find what A times C is. That's 5 times a negative 6, giving us a negative 30. Then we write out all of the factors of 30. And I say 30 because we're not going to be concerned yet on where we're going to stick that negative. Just know the negative can go on either of the terms in order to make it negative. 1 times 30, 2 times 15, 3 times 10, 5 times 6. Now our B in this case is a negative 6. So instead of last time we were adding our terms to get to the 20 because they were all positive, this time we're trying to subtract our numbers to get to 7. Well, 1 and 30, no matter how I go about it, is not going to subtract to give me 7. It'll give me 29 or negative 29, so that doesn't work. 2 minus 15 will give me a negative 13. 15 minus 2 gives me a positive 13. That doesn't work. 3 times or minus 10, that would give me a 7. So I'm going to be using 3 and 10. This is where I do my split. So I have 5x squared, and then I need to split my 7 into a 3 and a 10. Since I have a 5 on this first term, I'm going to put my 10 as my next term. And since I need to have a negative 7, I'm going to put my negative with my 10. because when I take negative 10 plus a positive 3, I have to get back up here to the negative 7. That's how you know where to stick the negative. Now we factor by grouping. We look at the first two terms and we say, what do they have in common? 5x, leaving us with an x minus 2. Then I look at my next two terms, which is a 3x minus 6, and say, what do those have in common? A 3, leaving me with the x minus 2. Again, what's inside my parentheses are the same, which was the whole goal. I pull that x minus 2 out front. That leaves me with a 5x plus 3 inside. This is exactly what we got earlier when we factored this one. Questions, comments, concerns, clarifications? Okay, I've got to change paper real quick. Too much on that one. We've got 2 more to do. C is again the same as the one we've done earlier, which is 3x squared plus 7x plus 5. But I like this one to show you again, it does work even if we're talking about our prime ones. You don't approach it any differently. Because theoretically, we wouldn't already know the solutions to these. We wouldn't have had already worked them. So my A in this case is 3, my B is 7, my C is 5. So A times C would be 3 times 5, which is 15. So this one's actually really nice because there's only a couple factors of 15. 15 is 1 times 15 or 3 times 5. There's no other factors for 15. So this is nice because I'm trying to find factors of 15 that would add together to give me 7. But when I add 1 and 15 together, I get 16. When I add 3 and 5 together, I get 8. Neither of those are 7. That's how I know it's prime. So you can even use the factor by grouping method even if you have prime polynomials or prime trinomials. It works. Nope, that's a 3. Last one. Since it's the last one, I'll make it the most fun. What do you notice first that's different about D than all the other ones that we've done?
They're all divisible by 5.
Okay, they're all divisible by 5. Anything else? So they all actually have an extra x as well that we could factor out. So this one we can do the factoring out of the greatest common factor, which is something we haven't actually done on any of the previous ones. So we can take out a 5x out of everything, and that would leave us with a 6x squared plus 11x minus 7. So now this 5x that's outside the parentheses is kind of just going to hang around. We're not going to do anything else with that at all. We're just going to focus on the 6x squared plus 11x minus 7 that's inside of here. That's the trinomial we're going to focus on. So when I go to the side to write my A, B, and C, I'm going to write my A, B, and C based on this newly factored version, not the original version. So my A in this case is 6, my B is 11, and my C is negative 7. I'm taking A times C, which would be 6 times negative 7, giving me a negative 42. So I need factors of 42. So I've got 1 and 42. I know it's even, so that would be 2 times 21. 4 plus 2 is 6. 6 is divisible by 3, so this is divisible by 3. It's going to be 3 and 14, and 6 and 7. These are all the factors of 42. Now, notice that I have a negative in front of my C, but I have a positive in front of here. If I have a negative in front of my C, that means my signs inside my binomials are going to be different, which means they have to subtract together to give me that middle term. So I need to look for factors of 42 that subtract to give me 11. Well, 1 and 42 is not going to do it. 2 and 21 would give me 19. That's not going to do it. 14 take away 3, that'll give me 11. So again, my 5x is kind of just hanging out here. Then I have my 6x squared, and now I'm going to write my 3 and my 14x to split up my 11x. My 11x is positive, so I need my 14 to be positive and my 3 to be negative. Since my first term is 6, I'm going to put my 3 with it. So I'm going to put minus 3x plus 14x minus 7. Again, the way that I determine where I'm going to put my 3 and my 14 is just by looking at what are the two terms out here and which ones kind of pair up better. If I would have switched those, 3 and 7 don't really have anything in common. It doesn't mean it wouldn't work. It still would work. It's just easier if they both have something in common. So again, 5x is still living out here in no man's land. I'm going to change that to a bracket just so that you really see the binomials inside of here. Because I'm looking at 6x squared minus 3x. What do those have in common? 3x, giving me a 2x minus 1. And then I'm looking for a 14x minus 7. What do those have in common? Positive 7. Again, giving me a 2x minus 1. So the only reason I changed to brackets is because I knew I was going to have parentheses in here, and it gets a little sloppy if we have parentheses and parentheses. Brackets mean the same thing. In my handwritten notes, I use parentheses. So I have the 2x minus 1, and then once I factor those out, I have 3x plus 7. You could find the factorization of this by using the trial and error method as well. It works the same way, regardless of which method you decide to use.